This video is going to review all of the things that you have to do on the 3.1 to 3.3 Algebra 2 quiz that are graphing. There are kind of two types of problems that you're going to see on the quiz. You're going to have ones that are done by graphing, and then you're going to have the ones that are done using algebraic means. That's covered in other videos. This is all about graphing. So the first thing you're asked to do up here is to solve the system by graphing, and then when you're done, you want to make sure you check your answer by plugging things in to make sure your answer makes sense. So your goal here is to graph the equations, and what you're looking for is you're looking for where they intersect. That is the goal of any systems problem, is to find intersection, whether you do it by a picture, by the graph, or by doing it using algebra techniques. So when you look at this first one, the first equation is in slope-intercept form, so I'm going to write down what the slope is. The slope is 2 over 1. The y-intercept is 5. And then I'm going to go on to my graph, and I'm going to graph that using those features. So here is my y-intercept. My slope, and I'm going to have to kind of extend. I'm going up 2 over 1. And then you want to draw your line. It really helps with these problems when you're doing it on a quiz to use the side of your agenda or the size of your test folder so you get a straight line, because the accuracy of your answer depends on the accuracy of your picture. The second one is in a standard form, so the easiest way to graph this is do that cover-up method. Cover up the y's, you get x equals 2. That gives me your x-intercept of 2. And then cover up the x's, you get y equals 2. So it gives you a y-intercept of 2. And then you're going to connect the dots with this one. And your goal is to see a point in which they meet. Now, when I ask you to do problems like this by hand, I am going to make sure that they meet at a coordinate that is definitely on the grid where you can see your integers. I'm not going to give you an answer something like 2.5 or negative 1.3. So this to me looks like it's the point negative 1, 3. Now, what I mean by check your answer is take that point that you believe is the intersection point and plug it back into both equations and make sure it makes them true. And you can do this in your head, you can do this on your calculator, but make sure that when you look at that top equation and you put negative 1 in for x and 3 in for y, you get a true statement, which you can do very quickly and say, well, that means 3 equals 2 times negative 1 plus 5, and realize that that is a true statement. You can do the same thing with the other one. Make sure that when you take negative 1 plus 3, you do get 2. So that is the way of checking. I am not going to ask that you show all of that because I know you do a lot of it either in your head or with your calculator, but it's something that you should be doing to make sure your answer is even a legitimate answer. Your answer then, when you write it, I circled the point. A lot of times on a quiz, it'll have a little line where it expects you to write the point. Make sure you give me the full coordinate, the x and the y. The second one, same directions. Same thing as far as the look. I have one that's in a standard form, one that's in a slope-intercept form. If you want to make all of them slope-intercept form, you're welcome to rewrite those and get y by itself. I'm going to keep it the way it is and just say, well, that means that 2x equals 7 when I cover up the y's. So x equals 7 halves, or 3.5 if you prefer the decimal. So I'm going to put that on my x-axis. And then y, I get negative y equals 7. So that means y equals negative 7. And again, I'm going to have to extend my graph a little bit. Negative 6, negative 7 down here. Connect. And again, you're probably going to be more accurate than I am writing on this board. I don't have a ruler that will lay flat enough for me to use, but using the side of your test folder will really help. For the next one, it's in slope-intercept form. My slope is 2, or 2 over 1. My y-intercept is 8. And again, I have to kind of go up a little bit here, go up to here. And I'm going right into my writing, up 2 over 1. And I get this line. And what you'll notice, even though it's really flying off my grid, is that when I look at it, they are not intersecting. And if you have ones like this, I'm going to make sure that if they are intersecting, it's very obvious. And if they're not intersecting, it's also very obvious. What you'll notice here, these are actually parallel lines. If you solved each of these for y and identified their slope, they would both have the same slope. That means they will never intersect. So what you need to do for your answer is either write in words, no solution, or the symbol that we've talked about throughout this course that means no solution is that circle with a line through it. What that is saying is there aren't any points that make them both equal. They never meet. So that is what you're going to write for something like that. The second and the final slide is also a graphing, but it's from the later section in this quiz, 3.3, and it's whenever you're trying to graph a system of inequalities. What helps with this and what we talk about in class is using different colors, getting your chance to see the shading, because that's what you're doing. And our goal is to figure out where the shading overlaps. So I'm going to do each of these individually, draw the boundary line, determine if the boundary line is solid or dotted, and shade. And in the end, my goal is to see where does all the shading that I do, where does it all overlap? That's what I'm looking for. So if you look at your first one, when you have the y greater than or equal to 1, you want to think about what does y equals 1 look like? That's a little bit too bright for you to see, I'm sure. So what does y equals 1 look like? We know that it is a horizontal line, and it's a horizontal line that goes through 1, and I'm going to make it a solid line. The reason I'm going to make it a solid line is because the inequality symbol has the or equal to. I want to shade everywhere that y is bigger than or equal to 1. So that means I'm going to shade above. So now I'm going to go back to a lighter color here and say, here's what I have so far. Then I'm going to look at the next inequality. I'll do this one in red. This one is saying, well, what does it look like if it's x equals 6? If it's x equals 6, it's a vertical line going through 6. So I'm going to extend just a little bit here, and I'm going to draw my vertical line. It's also solid because it had the or equal to. And I want to know when x is less than 6, so that's going to be to the left of this red line. So right now, my shading is going to overlap right here. So I'm above the blue and to the left of the red. I've got one more, and we'll get a nice purple color. And this one is not vertical or horizontal. It's a diagonal line. The slope is 2 over 1. The y-intercept is -5. So I'm going to go down to -5 and then use my slope up to right 1. Before you draw the boundary line, you do want to take a look and notice it is going to be dotted boundary line. So I'm going to draw it like this. And now we have to figure out where I'm shading now. Because it's in slope-intercept form, this less than means that I am shading beneath it, so I'm going to be under the purple. And what you have in the end, your final answer, is where all of the shading overlapped. And I'm going to try to make it as dark as possible so it's very obvious as someone is trying to grade this, where your regions overlap. There's a name for this, which you talk about this a little bit in class. We call this the feasible region. We're going to use that terminology a lot in the second half of the chapter. What that means is any point that's in that heavily shaded area would make every single inequality true. And that's what you're finding. And that's your goal in your quiz, too, to come up with all that shading and then to see where does the shading overlap. Shade it as dark as you can, and that is your final answer.